Welcome back to another stream. Today we're going to go through from start to finish, building the Marqs Super Nintendo and NES Dejitter board. So, basically, there's a few reasons that I'm doing this video. For one, it's another thing that I do, which, I try to stream everything that I do. But a big part of why I'm doing this is because so many people, early on, whenever this mod first came out, it was kind of a Wild West kind of situation where there was nowhere you could buy it. So your only option was to build it. And as I've said before, I was one of the earliest adopters of the mod and installed it on a lot of consoles before anybody else really was. I tested it out on most revisions of the Super Nintendo motherboard. So yeah, the installation guide you see on the GitHub for this project, most of them are mine. For the Super Nintendo, at least. But also, at the time when this first came out, people were having a lot of trouble programming it. I had a lot of trouble. People in the thread where this was being developed at the Shmups forum, they had a lot of trouble. It was not easy to program. So I'm going to show the process that I use now to program completely flawlessly every time. And I think it'll be easy because I'll be doing step by step everything you need to do to set up your computer and get it ready to properly program these boards. So let's go ahead and get started building the board, and then we'll move on from there and do the programming. So we have a stencil from Osh Stencils to make the solder application as easy as possible. We're using version 1.2 boards. They're more or less the same as the later version 1.3 board that's on Oshpark now. I bought a whole bunch of these back in the day, and so I haven't needed to purchase any more since the initial run. Whenever I did purchase a large quantity of them, that was back when the 1.2 board came out. So to me, this is totally adequate. But if you're purchasing a new copy of this, you'll probably be purchasing the 1.3 board rather than the 1.2, because I think that's pretty much what's available on Oshpark at this point. I don't even know if you can get the 1.2 board anymore. The 1.3 board doesn't change much. I think some layout stuff changed, but that was about it. The 1.2 board was the big update that had all the jumpers to make it easier to install in more different consoles and everything. So no real disadvantage to the 1.2 here, and nothing really changes as far as installation is concerned. So let's go ahead and pop this loose. And a little tape square holding it in place. And let's get you to a better layout here. And we'll start populating the board. So it looks like the very this end of the CPLD pins didn't get fully solder pasted, but that shouldn't be a problem. Okay, I guess we'll just start with the PLD. These PLD packages are so much easier to work with than the finer pitch, like the FPGAs or even like the Max 2 CPLDs that we use in the N64 RGB mod. Because the pitch is so much coarser and it's so nice. So easy to work with. Solder paste works without bridges. It's very hard to run into issues with it. Okay. Let's see here. Let's start working from this end here. So C1, that barely got any solder paste too. I'll have to come in there and, you know what, while we're already here, I'll just go ahead and solder this one in because I don't want to forget about it. That can get you in trouble. Okay, we'll clean that up when we reflow the board. Oh man, none of these capacitors got it either. Okay, we'll do those last. All right. So R8. R7. R4. R5. Yeah. Populating these boards is, you know, pretty much always the same. Just kind of sit here and put things in the place they go. Nothing too exciting. C3. Now, I would normally do these in larger batches, but I wanted to keep it to one board today so that I could demonstrate start to finish how this is done and give you the best possible kind of overview. Hold on just a second. Alright, I'm back. Unexpected visitor. Not really a visitor. My sister showed up. Was not expecting her to be here today. Okay. Let's see here. Okay, so all we have left is this end over here that didn't get any solder paste, which is a shame. Maybe I can get a little paste on there. Let's see here. I know that looks quite terrible, but that's the best I can do right now. I'll clean it up with the iron if I need to. Okay, we got R6. C6. And C5. Alright, that's it for the surface mount components. Oh no, we lost a capacitor. Okay, that's good there. Let's try to get C1 kind of sort of situated. Okay, that's that for C1. Okay, done there. Let's take a look under the microscope. Yep, it all looks pretty good to me. So, all that's left is to add in the crystal and program. This was a crystal pulled from a Super Nintendo, so it's not a new one, although I do have new ones as well. But I like to reuse the ones that come from the Super Nintendos, because why install new crystals when you got perfectly good originals that work just as well? Okay, one thing I will do right off the bat is trim the legs of this crystal, because they do poke out quite a bit, and they just cause problems later on for the installation. But yeah, there you go. That's a finished board. So now we can go ahead and program it. So what we're going to be using to program this board is the Adafruit FT232H breakout board. This one right here. So this is pretty cheap. I think it's about $15, $20 on Amazon. I suppose you could get it from Adafruit's website as well. It's an FTDI FT232 breakout board. And basically it just has a number of different protocols to it that it can do. One of the things it can do is JTAG programming. So we're going to use a special driver for this. I'll show you how to set that up. I'll show you how to get this board set up on a Windows computer to function properly with the OpenOCD, so that we can, which is the software we're going to use to program this. I also made a little cable. I used just these standard little hookup cables. I forget what these are called, but these standard little jumper cables. I created a jumper that is pinned out properly. I'm not going to show that part of it, but I'm going to link you to the configuration information that tells you what pin goes to what. So you should be able to figure it out yourself. But everything else we're going to go through, and we're going to program this up. So let's switch over to the computer, and let's start looking at things. Okay, first thing we're going to do is get OpenOCD. So OpenOCD does not come from the creators. as a compiled binary anymore. They used to compile binaries for it, now they don't. So they expect you to compile it yourself. I've never done that. I don't want to do that. We're not going to go through that today. What we're going to do is I'm just going to direct you to a place that you can download the completed binary. It's newtoolchains.com. I've got a link down in the description. They have all the binaries for Windows and Linux. What you want is the newest version with Win32 support. So that would be like this one here. So what we're going to do... Sorry about that. What we're going to do is we're going to go ahead and open up my folder that I already have the binaries in, right? And we're going to go to bin here. There's a few things we're going to set up here, but before we do this, so this is OpenOCD. It's a command line based piece of software for running the JTAG flashing. So few things we're gonna need. We're gonna need to set up the drivers for this FT232, and the way we're gonna do that is we are gonna go. So this article from Adafruit tells you how to set up the libUSB driver, which is what is needed for the OpenOCD to use the FT232 chip in here properly. So let's go ahead and get a USB cable hooked up. Now I've already got this configured properly on my computer, so I'm not going to show the whole process, but I'm going to walk you through what you need to do to be able to set this up. So to get the proper driver, just like this article, this Adafruit article says, you're going to go to this website here called zadig.akio.ie. I've left a link for this in the description as well. You're going to download this program, and you're going to use it to install your driver properly. So when you download this program, you're going to open it up, and it's going to look like this. And you're going to have a drop down that you use to select your device. So we're going to create a new device. We're going to list all devices, and we're going to use this to find our interface. So what we have here is a USB serial converter. This is the correct one here. You see I also have my USB blaster and all that stuff. You're recommended to unplug everything that's not like your keyboard, your mouse, any kind of potentially like serial converters or any other kind of COM port communication stuff that is not your serial converter that you're using through this FTDI chip. You're meant to unplug pretty much everything so you don't make a mistake. But basically, you're looking for a serial USB converter, and for driver, we're going to go down to libUSB-K. Then you would do you wouldn't do reinstall driver, you'd do replace driver. As you can see, currently I already have the libUSB-K driver installed, so it's everything's already set up here. So we're not going to do this part, but this is what you would do if you were setting this up for the first time. So now the FT232H breakout board is installed with the correct driver for what we're trying to do here. So the next part we're going to have to get set up is the FTDI config file. I've also left a link to this. This is specifically a config file for the OpenOCD, for the FT232H for OpenOCD. So this contains the configuration of what OpenOCD is going to be looking at for this particular board. So as you can see here, it shows you right here which of the pins, the digital pins on the adapter, you're going to plug up to which JTAG pin. So on the Dejitter board, the JTAG pins are actually listed out. Let's see here. The JTAG pins are actually listed out here on the Dejitter board. You can actually see them right there. So you have 5 volts ground, TCK, TMS, TDI, TDO. The silk screening is not fantastic on this board, but these are cheap boards. So that's the actual pinout for these. So what you need to do is you need to create a little cable that matches the correct pinout that goes from the digital D0, D1, D2, D3, D4 to the appropriate pins on the Dejitter board. So that's basically how that works. I've already worked up this cable here that is wired properly for that. So we just plug it in, and then we can just attach it to the Dejitter board. So the next part we're going to go through, I'm going to go back to here, and we're going to look at what you could do is you could just copy and paste this into a text document. In this case, we're going to show the one that I created. So in here, this is FT232H OpenOCD.CFG. This is really just a text file that I dropped, that I copied and pasted that information from the GitHub that we were just looking at. Copied that information, pasted it in here. The only thing you need to do on here is you need to uncomment the transport select JTAG portion, because normally that's commented with the little hashtag here, like that. You just need to delete that hashtag so that this is selected as JTAG. So now we have the CFG file configured up. And we just place that in the same directory as the OpenOCD bin files. So then the next thing we need to do is we need to drop our Dejitter file in here so that it's in the same root directory. So the SNES Dejitter.svf, that's the file that we need to program. And then right here, I made a batch command, which just gives the parameters for OpenOCD to launch properly. So basically the batch command is what you use to actually launch the OpenOCD program. And it basically just says OpenOCD-F FT232H OpenOCD.CFG. What this is doing is it's telling OpenOCD to launch using the FT232 OpenOCD configuration file. That's really all there is to it. So if we launch it right now, nothing's hooked up to it. Nothing's hooked up to the adapter board. So it probes, looks for something in the JTAG scan chain. It doesn't find anything, so that's all there is to it. So we're not worried about that right now. The next thing we need to do is we need to go get PuTTY. And PuTTY is a telnet client. So you just go to putty.org, you download PuTTY. I'm not going to download it because I already have it installed. But PuTTY is a telnet client that you're going to use to connect to your OpenOCD and basically send commands to it. So let's go ahead and get ready to actually launch this and program this chip. So what you need to do, you don't have to install headers on the board. You can actually just take a cable with these kinds of pins on the end of it, and you can just line it up properly. So in this case, I've already got the header aligned properly for use with the Dejitter board. So I'm just going to poke it through the holes here and apply a little bit of pressure on the board. Just tilt the board a little bit so that those pins make good contact. Now we're going to go ahead and run the batch file and launch it. So you see that instead of saying that nothing was found, it says JTAG tap, auto0.tap, tap device found, atmel device, blah, blah, blah. So that's all good. That's ready to go. Now the next thing we need to do is launch PuTTY. And I already have a pre-configured PuTTY configuration here, but all you need to do, if you're running the PuTTY instance on the same computer as the OpenOCD then installation, then what you need to do is put in 127.0.0.1, and your port is going to be 4444. It's a telnet client, or it's a telnet connection, so you're going to select telnet, and that's it. You open that up. You see now we have Open on Chip Debugger. Right, so the next thing you need to type, and I just stored this in a little text file so that I always remember it. Since your Dejitter file is in the same root directory as the bin files, all you have to do is type in svf/snes_dejitter.svf. So that's in there. You hit enter, and it programs. There you go. Programmed successfully with 0 errors. So that's all there is to it. This is a completely finished Dejitter board. And it really is incredibly easy to program when using the FT232 board. Because, you know, some people are using Raspberry Pis and things like that. That does work. That's how I originally programmed my, my original Dejitter boards that I built. But it doesn't work very well. You get a lot of failed programs. You oftentimes run it several times before it finally successfully programs. It's a real pain. This works every single time, and I think the main reason is that this is signaling at 5 volts, whereas the Raspberry Pi GPIO, I think, signals at 3.3 volts, which is, I mean, the chip is designed to be programmed at 3.3 volts, but the Raspberry Pi, the GPIO is not, I guess it's probably just not optimized for doing JTAG. You know, it's not buffered in any way. It's not meant for programming, for JTAG programming. That's just not what it's for. You can make it work, but it doesn't work very well. This is for that. You know, this FTDI chip is built to do JTAG, SWD, you know, all kinds of different programming protocols. So it's really perfect. You know, yeah. So that's what I would recommend doing. There are a couple other FTDI breakout boards that will work for this, but I just went with the FT232 because it's cheap, it's readily available, and it works really well. So I hope that kind of clears up how you do this. It's really not that hard to do, especially if you have the correct programming tools available. OpenOCD can be kind of daunting to use, mainly just because it's a very user unfriendly interface. The interface for this is very it's terrible in terms of user friendliness. It's extremely opaque, but with a good guide, you know, walking you through what you need to do, it's really not that bad. But anyway, I think that's all I had for you today. Hope you enjoyed it, and I hope you'll join me next time. Thank you.